Hello everyone. I welcome you all to the 8th session of Data Analytics with R. I am Kiteshwari Mishra, your instructor for today. Already we have covered topics like constants, variables, data types. So the next one we will discuss today is operators. Lot more to cover. So without wasting much time, let us go to the definition of operators. What are operators? Operators can be represented with a symbol that tells the compiler or the interpreter to perform specific mathematical or logical manipulations. In many operations, an operator is needed. Many types of operator is present in R. R is a rich set of built-in operators. They are arithmetic operators, relational operators, logical operators, assignment operators, and miscellaneous operators. So these operators I have listed out and classified as follows, and I will go to the demonstration immediately after this so that you can better understand all these types of operators. So let us move to R Studio. Okay, the first one is arithmetic operators. You can see I have listed out some of the arithmetic operators: plus, minus, asterisk, slash, double percentage, then percentage slash percent symbol. So all these are arithmetic operators and each one of it has a different role. They are binary operators. I hope you are confident in the concept of binary operators and unary operators. Binary operators means it needs two operands to operate on. That means plus operator stands for addition. It performs addition, and with what it will add, it will add two things. So it needs two operands. So plus is a binary operator as because it is in need of two operands. Similarly, minus is also a binary operator when it is performing subtraction. But minus can be referred to as a unary operator when it changes sign of a particular value. So similarly, we can go to the next operator, that is asterisk operator, which stands for multiplication of two operands. So it is also a binary operator. Next is slash, which divides the divisor with the it divides the dividend with the divisor. So it needs also two operands. So it is a binary operator. This person symbol, this is the modulus symbol or the remainder symbol, which finds out the remainder term in any division operation. This person slash person, this is an operator which finds out the quotient in any division. So these are all binary type of operators, and these are all termed as arithmetic operators as because they perform arithmetic operations. So to demonstrate this, I have taken three variables, var1, var2 and var3, and I have assigned some numbers arbitrarily, like var1 is 24, var2 is 8, var3 is equal to 7. So now let us execute this. How to run? You can see Control Enter is the shortcut key to run the first statement. Then I have, you see, var1 is been assigned 24. So how do I know? In the environment, let us check the environment. I have deleted the previous variables, whatever I have created. Now I will assign 24 to var1. Press Control Enter to execute. Now you see 24 is stored in var1. var1 is created in the as the environment object and 24 is assigned to var1. Similarly, I will press Control Enter again to assign 8 to var2 and 7 to var3. Now I want to see what is the result of this var1 plus var2. This will be performing an addition operation and it will return a value. This var1 plus var2, if somewhere it is written, then it will perform the addition operation and it will return a value. So you can see, I can print this. It is returning the value of var1 plus var2. What is var1? It is 24. What is var2? It is 8. So 24 plus 8, it is writing as 32. So it is performing addition operation. Similarly, var1 minus var2 is performing 6. var1 multiplication by var2, it is 192. Then var1 divided by var2, it is 3. As because it is divisible, as because 8 is 24 is divisible by 8, so it is performing correct division and there is no remainder at all. If we will check that what is the remainder term by the percent or module symbol, that percent symbol, double percent symbol, then you can see when I'll execute this particular statement, you see the remainder term is 0. That means it is divisible. So remainder is 0. Okay. Then you can see that I have taken another variable that is 7 as var3. So let me divide var3, var1 with var3 so that I can check the remainder. What is the remainder here? So I will execute, I will run this statement and you see the remainder is 3. That means whenever I will divide 24 by 7, 7 3s are 21 and the remainder is 3. So the remainder term it is finding out. I hope you will be able to understand this one. Similarly, if I'll go for var1 divided by, let's say I'm typing here, var1 divided by var3. Now you see var3 is, var1 is not a multiple of var3, that means 24 is not a multiple of 7, so it will not divide. So what result it will give? You see 3.428571. It is giving the double type value as outcome of this division. But I don't want this thing. I want that what is the quotient value? That means what is the, as because it has shown the remainder term as 3, I want to get the quotient value here. So to get the quotient value, var1 mod slash mod var3. You see, the quotient is also 3. You can also get it from here, but this particular operator, this operator gives the quotient value directly. Okay. So this is all about your arithmetic operators. Next, we will go to the relational operators. What are the relational operators? The relational operators are less than equal to, greater than equal to, then not equal to. So all this set of operators, they are comparing one operand with another operand for equalness. Okay. So whenever we will use this less than operator, it will check that whether the previous operand is less than the latter. And accordingly, if it is, it finds it true, then it returns true. So the expression which is created by all these operators are Boolean expressions or logical expressions, because the resultant of this operation is either true or false. So let us check it out. So I have listed all the expressions here. var1 less than var2. What is var1? var1 is 24. What is var2? var2 is 8. So the first expression, that is var1 less than var2. So this will check that whether 24 is less than 8 or not. So what do you say? 24 is less than 8? No. So the resultant of this particular statement will be false. You see, it is returning false. Similarly, if I check that where 1 less than equal to, that means it is checking the equalness along with the less than. So again it will be false because 24 is neither less than nor equal to. So it will again be false. You can mark this. Similarly, the next statement, that is var 1 greater than var 2. Now 24 is greater than 8. So this statement will return a true. You see, a true is returned over here. Let me clear this console so that you can better have a view. Control L is to clear. Now you can see that var 1 greater than var 2, this expression will result as true. Similarly, var 1 greater than equal to var 2, as because greater than is satisfied, so it will not, it will also check the equalness, but even if this is not true, but the greater than is true, so it will return a true. Okay. Now, equal, this operator will check the equalness of both sides. That means if var 1 is equal to var 2 or not. So let us check it out. As because 24 is not equal to 8, we told that in the previous classes we have discussed that constants, they remain same, they are fixed quantities, so they never change the value. So 24 is not equal to 8 and it returns false. Similarly, the next one, that is var 1 not equal to var 2. Now 24 is not equal to 8. So this statement, this expression will result into true, as because 24 is not equal to 8. So these are the relational operators which is responsible to create relational expressions, and whenever this is tested in some conditional statement, they will return either a true or a false. Next comes the logical operators. Logical operators, they are used to combine the logical expressions. They are used to form logical expressions with the help of another logical expression. So how they will be formed? You see, the logical operators are ampersand. This is the ampersand symbol, mostly termed as AND operator. Then this bar symbol. This bar symbol says stands for OR. This exclamatory symbol, this stands for NOT. Double ampersand, this stands for AND again, and double bar, this stands for OR again. So now there is an ambiguity to understand that what is this single ampersand, what is this double ampersand. Okay, I will go to the detail of this two. I will differentiate this two with example, but first let us check that what it does. Now, as I have told that logical operators create logical expressions or find out logical values or evaluate logical expressions with the help of logical expressions. That means whenever I have two or more than one logical expression, then I can use this operators. So you see, var 1 greater than var 2. This is a logical expression. This is a relational expression with logical outcome. Similarly, var 1 greater than var 3. This is another expression which is also a relational expression and a logical expression. So, ampersand or double ampersand will check that whether both the expression before and after this operator is going to return a true or not. So, and checks for the trueness of both the operands, both the logical operands previous to that and after that. And whenever both it will find true, then only it will return true. Okay. So it returns true or false based on the trueness or falsehood of both operands, both sides. Okay. So now you can see in var1 we have 24, in var2 we have 8, in var3 we have 7. So I'm checking var1 greater than var2. This expression already have given us true because 24 is greater than 8. This expression, that is var1 greater than var3, this expression will return a true also because 24 is greater than 7 also because var3 is 7. So both sides it has true. So the entire expression which is formed by the logical operator double ampersand is going to return a true. You see, it is giving true. So similarly, in place of this double ampersand, I will give single ampersand and I'll run it. It will also return true. It is also returning true. So now you may ask that what is the difference between this single ampersand and double ampersand, as because both are returning true, so how they are different from each other and why there are two operators. So for this I have an example, and this is beneficial for the bigger data structure, not for single variables like this var1 var2. So they are helpful in comparing bigger data structures. So I have created simple data structure x and y. They are vectors. They are vectors of logical values. They are logical vectors or the vectors with logical values. So in AX, I have created a vector. Do not worry about the syntax. I will discuss the syntax in detail in the forthcoming classes. So just understand that here I have created a vector called as X, which has three logical values, true, true and false. Similarly, I have also created another vector, that is Y, with three logical values, that is true, false and false. Now I will store the result of this expression x ampersand y, that is x and y. So it is checking for the trueness of both x and y. So now what it will return? You see, when we have compared one by one, then it is returning only one true or one false. Now as because it is ampersand, single ampersand, you check what is happening. X has this, y I have executed, then result I have executed. You see in X, in the environment, you see true, true and false. Here y is true, false, false. Now X and Y have been created. Result 1 also it has been created. Now let us print the result 1. So what is the value of result 1? That is true, false, false. How it has been generated? So in ampersand, in single ampersand, both the vectors are compared with their individual elements. Like the first element is compared with the first element. The second element is compared with the second element of the second vector. The third element of the first vector is compared with the third element of the second vector. And what are the individual results? First one is true, second one is true. So in this comparison results are true here. Second element of the first vector is true, second element of the second vector is false, so the result and value is false. Third element of the first vector is false, third element of the second element is false, so the result and value is false again. So ampersand or single ampersand and operator, this is bitwise, and we call it as bitwise, and it compares this to the root label or to the binary label of comparison. It does the binary label of comparison so that it compares all the elements individually and results this. In the same way, if you use this ampersand, in case of, you see, after this, I will create a value called result2, and here I will store x double ampersand y. Now just execute. What do you see? You see an error. So what is the error? So the result, the double ampersand checks for the trueness a falsehood of the first expression with the trueness and falsehood of the second expression. Now it doesn't find any true or false out of the first expression and any true or false out of the second expression. So as because x and y are vectors, logical vectors, not logical expressions, so it is finding that in the first one it calculates the length as 3, which is which it matches to the length of the next one, which it considers as one element, one expression. So ampersand, double ampersand, it checks for the trueness and falsehood of both the expressions, both the logical expression, not vectors, not the data structures, not any other structures. So ampersand will return an error here in this case. Okay. So to test the vectors, to test the element wise operation, element wise logical operation, you must use the single ampersand, not the double ampersand. Okay. If you check out this individually at your own end, then you will be able to understand this difference. Okay. So to output this, set the output of this AND operator, you see it is having length 3, so it cannot be compared to length 1 of the second logical expression. So here I have created another vector, that is, it is a vector. Now in Y I have put one value, that is false. Now I just wanted to print x double ampersand y. That means x and y. So it again checks that the first one is not a logical expression and it finds that the length is 2. And in the second one, the length is, it is finding as 1. So it doesn't checks individual elements. So it checks it as a whole expression. So it results an error. Okay. Now, next type of operator is assignment operators. Yes. In logical operators, we have OR operators true. In logical operators, we have OR operators. So in the same type, you see, result 1 is x ampersand y. I want to store result 2 as x or y. That means x bar y. And I want to print result 2. So you see, control enter. Result 2 is x bar y. Well, let me clear it again. Result 2 is x bar y and I will print it. So it is returning true. One more time. You see, true, true, false. True, true, false. So the difference between and or, if you know the logic table, you can very well know that when two expressions, let me create a logic table here. Let's see. So this is first expression. This is second expression. Second expression. Okay, just do one thing. Okay, just do one thing. Just wait a while. First expression, second expression, if we'll use and, if we'll use or. So what will happen if the first expression is true, second expression is false, then and will check that both expressions should be true. Otherwise, it will return a false. So you see, the first expression is true and one of it is false. So it will return a false. But in case of or, it will check that either of the expression should be true. Then it will return true, otherwise false. So here it gets that the one of it is true, so it returns true. Similarly, if the first expression is true, first expression is false, second expression is true, and will return a false because it finds again that one false is here. So it doesn't find both the conditions are true. So it will return a false. But in case of or, as because it says a true here, so either of the expression is true, so it will return a true here. Next, the first expression is true, the second expression is true, so and will return a true because it checks that both the expressions are true, so it return a true. And similarly, or one true, that means sufficient enough, so it will return a true here. The first expression is false, second expression is false, and will definitely return a false because it doesn't find any true here, so it will return a false. And here in or, it doesn't find any true, even one true is there, so both are false, so it will also return a false. So this is the truth table or logic table. So accordingly, these operators and or, they will behave. This one and this one, they both are and operator, and this one and this one, they both are or operators. So they will behave accordingly. Understood? Okay. So now, okay. Next is not operator. Not operator means it is negation. That means whenever the initial expression will be true, the not of true will be definitely a false. Similarly, the initial expression is false, then not of false will be resulting into true. So it is the negation operator or not operator, and which is represented with an exclamatory symbol. How? Let's see. So let us check. I have where 1 is greater than where 2. This expression results true because 24 is greater than 8. You see, it will result a true. Now I will check that. I will check that not of negation of where 1 greater than where 2. You see what is the output? The output is false. Because the negation of the initial expression, initial logical expression, is the opposite of it. If the initial expression is true, negation of true is equal to false. Again, if I will find the negation of the whole, suppose I will write negation of, again negation of where 1 greater than where 2. You see, the first one, the inner one, inside one will have true. This one will have true. The negation of it will return a false. And the negation of the whole, negation of false will return a true. So this statement is going to return a true. Got it? So this is how negation works, not operator works. Okay, now let us go to the next type of operator, that is assignment operator. Assignment operator is like this. You already know this one, and this one. You see, already I have told you during the variable creation. So A is assigned the value 2 like this with the left assignment operator. B is assigned with 4 with the equal to operator. And C is assigned a 6 with the right assignment operator. You see? So in the right assignment operator, you need to write the value first, then assignment operator, then the variable name. So in this way, you can assign values to the variable. So these are assignment operators. Now, two more assignment operators are introduced here for you. That is, one is a arrow, double left arrow and double right arrow assignment operators. So these operators are assigned, that are used to assign to global variables. These are used to assign the local variables, but these are used to assign the global variables. So what is the concept of this local and global? We will be discussing in the function chapter. Whenever we'll go for the function, we'll be discussing this local and global concept. Okay. But for now, you just understand that this operator gives the opportunity to assign the global variables from inside the function. Being inside the function, you can access the global variable and you can change the value of the global variable by this assignment. Okay. And it is having the similar structure. So whenever we are using left global assignment operator, we use at the left hand side the variable will be there and the right hand side the value will be there. And if you are using the right global assignment, then you can use the value at the left hand side and the variable at the right hand side. Okay. Next. Then we have some miscellaneous operators. So what are the miscellaneous operator? I have listed out 3 here. You will get lot many miscellaneous operator in due course of time, and it is not possible to list out all these things. So I have listed out only 3. The first one is colon operator. So why for this colon operator? This creates a series, this creates a sequence, this creates a range. So I want to create a vector, or I want to create a series of numbers and assign to xx. So in XX, I have stored the values from 1 to 10. How to store the value from 1 to 10? So this is the shortcut. This is the shortest way to store the values from 1 to 10 in Excel. You see, if I'll create this and print XX, then you see all the values it has from 1 to 10. You can check out here in the console. It is having all the values. It has stored all the values from 1 to 10 in XX. Okay. Now the next operator, that is percent in percent. So this checks that whether the left hand side variable is present in the right hand side variable. So I have created y and store a 2 here, and I want to check that whether 2 is present in xx or not. So how to check? I have created this expression that y percent in percent xx or not. So this will result true or false if it finds y in Excel. Now you just tell me that whether 2 is present in the range of 1 to 10 or not. Yes, it is present. So this will return a true. Yeah. Now I'll perform this one. You see, this is resulting a true. Earlier y has a vector, so it is not resulting, it is giving different outcome. So I have changed y to 2. Now I have given the expression and it is returning a true here because 2 is present in this range. Okay. The third operator, that is percent asterisk percent. This is used to perform the matrix multiplication operation. So do not worry about the syntax of how to create the matrices. but we will be discussing all these things in the forthcoming classes. So just hold on. I have created matrices like M1, and you see this is the M1 matrix. Let me clear once again and again perform it. Matrix and printing M1 and M2. You see, for matrix multiplication, you must have the number of columns in the first matrix should be equal to the number of rows in the second matrix, so that a matrix multiplication will be possible. So how to multiply these two matrices? This is the expression, and I have used this operator, percent asterisk percent. Okay, let us check it out. You see the multiplication happened, and this is the resultant matrix. Okay. Similarly, one more operator also I have listed, that is in one line. If you want to perform multiple statements, then you can make use of this semicolon operator. A is equal to 9, B is equal to 2. So I can use two lines to execute this. But suppose I want to execute it in one line, then I can make use of this semicolon operator and I can perform. You see, in one go, control enter, both the things will be executed, and you see in A I have stored 9 and in B I have stored 2. You mark the variables here. Okay. Here we have created. Okay. So in this way, we can make use of these operators in R. So I hope you like this particular session and know so much about the operators of R. All the operators we have discussed. So in the next classes, we'll be discussing regarding the control structures and functions and data structures and so much more. So just check it out in the next videos. So for this, for now, uh, I remain here, and let's meet in the next video. Till then, have a great day, great learning. Thank you very much.